Hello everyone. I hope you all are doing well. Welcome to today's physics class. Today we are going to start a very important chapter, electric charges and field. So before we begin, I want to ask you a simple question. So the question is, have you ever wondered why two magnets attract or repel each other? So most of you will say because they are magnets. That's absolutely correct. But now let me ask you another question. Can attraction and repulsion happen even without magnets? So the answer is yes, absolutely. There are many situations where objects attract or repel each other without being magnets. Okay? और ये attraction repulsion किस वजह से होता है? So the answer lie in very important property of a matter called electric charge. And that's exactly what we are going to study in this chapter. So before moving ahead, let me tell you one thing. Electrostatics is not just another chapter in physics. It is a foundation of electricity and magnetism. So this chapter is foundation of upcoming chapters. Okay? अगर आपको इलेक्ट्रिक फील्ड, इलेक्ट्रिक पोटेंशियल, कैपेसिटेंस, करंट, इलेक्ट्रिसिटी और अपकमिंग चैप्टर्स जो हैं वो अच्छी तरह से समझने हैं तो यू हैव टू मेक योर फाउंडेशन ग्रेट with the help of this chapter. Okay? So we will focus on understanding the concept from very beginning. Okay? Because once the concept is clear, formulas become easy and physics start making sense. So by the end of today's lecture, you should be able to answer the questions like what is electric charge? What is electric charge? And why do objects become charged? And why do some objects attract or repel each other? Attract or repel each other? Okay. And what are the basic properties of electric charge? Properties of electric charge. Okay. So these are the questions we will answer step by step. So without wasting our time, let's begin our new unit, electrostatics. Okay. So now before jumping into concept, let's first understand what we are going to learn in this chapter. Okay. So whenever we start any new chapter, it's always a good idea to know its roadmap. सो अगर हमने डेस्टिनेशन का ही नहीं पता होगा तो जर्नी एंजॉय करना भी डिफिकल्ट हो जाएगा. सो लेट्स टेक अ क्विक ओवरव्यू ऑफ टुडेज चैप्टर. सो एज you can see on the screen, this chapter is divided into four important sections. So the first section is electric charge, means understanding the charge. तो यहाँ हम सबसे बेसिक क्वेश्चंस का आंसर ढूंढेंगे, जैसे कि what exactly is electric charge. तो हम यहाँ पे देखेंगे what exactly is electric charge. Okay. एंड कि ये चार्ज आता कहाँ से है. ओके. और किसी ऑब्जेक्ट के पास चार्ज जनरेट कैसे होता है. ओके. सो वी विल बिल्ड दिस कंसेप्ट फ्रॉम एटॉमिक लेवल. ओके. एंड द सेकंड सेक्शन इज प्रॉपर्टीज ऑफ चार्ज. हर फिजिकल क्वांटिटीज की कुछ प्रॉपर्टीज होती हैं. मास की प्रॉपर्टी होती है, फोर्स की प्रॉपर्टी होती है और चार्ज की भी कुछ फंडामेंटल प्रॉपर्टीज होती हैं. ओके. जैसे कि Can charge be created or destroyed? So some basic properties are, can charge be created or destroyed? Another is, क्या चार्ज हमेशा कंजर्व रहता है? हमेशा कंजर्व रहता है? एंड थर्ड इज, कैन चार्ज एग्जिस्ट इन एनी वैल्यू? या फिर उसके भी कुछ फिक्स वैल्यूज होते हैं? सो वी विल आंसर ऑल दिस क्वेश्चन विद proper reasoning. And the third section is example and numerical. Okay, which is practice and application. Okay, physics, because physics is not about remembering formulas. Physics is about understanding concept and applying them. इसलिए हर important concept के बाद हम example solve करेंगे ताकि concept और numerical दोनों strong हो जाएं. Okay, and last one is charging of a body. We will study how the body get charged. Okay, हम समझेंगे कि एक न्यूट्रल बॉडी को चार्ज कैसे एक्वायर करती है, जो एक न्यूट्रल बॉडी है वो चार्ज कैसे एक्वायर करती है. सो हियर वी विल डिस्कस द थ्री मेथड ऑफ चार्जिंग. ओके, थ्री मेथड ऑफ चार्जिंग here we discuss. One is charging by friction. Second is by conduction. Third is by induction. ओके, और हैंड में हम कुछ अर्थिंग के कॉन्सेप्ट भी समझेंगे, क्योंकि प्रैक्टिकल लाइफ में इलेक्ट्रिकल सेफ्टी के लिए सबसे इम्पोर्टेंट कॉन्सेप्ट है अर्थिंग. ओके, so now I want all of you to notice one thing. This chapter is not an isolated chapter. ये चैप्टर आगे के आने वाले ऑलमोस्ट सारे इलेक्ट्रिसिटी के टॉपिक्स को की फाउंडेशन है. ओके, सो if your concept of electric charge is strong, then electric field, electric potential goes low, and even capacitance will become much easier to understand. So today our focus is not on memorizing definition. Our focus is to understand the concept deeply. Okay, now we know that the roadmap of this chapter. Let's begin the most fundamental question. What is electric charge? So before moving to the next slide, why this chapter matters? So this chapter matters because this is the foundation of upcoming chapters, yeah, upcoming units. Okay, now let's move to the third slide. Okay, so the third slide is understanding charge. So let's begin our first topic, understanding charge. So before I give you a scientific definition of electric charge, I want you to think about simple question. What do you think is the reason behind the attraction and repulsion between two charged bodies? Okay, so we answer this question exactly. The reason is electric charge. Now many students have a misconception that charge is something we can actually see, but that's not true. Just like we don't see gravity बट वी कैन ऑब्जर्व इट्स इफेक्ट, वैसे ही हम इलेक्ट्रिक चार्ज को भी डायरेक्टली नहीं देख सकते, लेकिन उसके इफेक्ट को इजीली ऑब्जर्व कर सकते हैं. सो फॉर एग्जांपल, जब दो चार्ज बॉडी एक दूसरे के पास आती हैं तो उनके बीच में एक फोर्स एक्ट करता है. कभी वो एक दूसरे को अट्रैक्ट करती हैं और कभी रिपेल. ये अट्रैक्शन और रिपल्शन ही हमें बताता है कि इलेक्ट्रिक चार्ज प्रेजेंट है. सो इन सिंपल वर्ड, इलेक्ट्रिक चार्ज इज द प्रॉपर्टी ऑफ अ मैटर दैट इज रिस्पॉन्सिबल फॉर इलेक्ट्रिकल इंटरेक्शंस. सो अब एक और इम्पोर्टेंट क्वेश्चन है, इंटरेस्टिंग क्वेश्चन है, क्या हर ऑब्जेक्ट चार्ज कैरी करता है? सो द आंसर इज यस. सो इवन ऑब्जेक्ट इज so every object we see is made up of atoms, and every atom contains charged particles. Okay, so normally object appear electrically neutral because positive और negative charges are equal. लेकिन जब ये बैलेंस डिस्टर्ब होता है तो ऑब्जेक्ट इलेक्ट्रिकली चार्ज हो जाता है. इट्स अ कंसेप्ट जो हम आगे एटॉमिक स्ट्रक्चर और चार्जिंग मेथड्स में थोड़ा डिटेल में समझेंगे. So for now, just remember one important idea. No electric charge means no electric force. Okay. So no. Okay. Let me change the pen. Why we can't able to write? Let me see. Draw. Okay. Yes. Now we can write. We can able to write. So understanding charge. For now, no electric charge means no electric charge means no electrostatic force. Okay, no electrostatic forces. That's why electric charge is the starting point of the entire electrostatic unit. Okay. So let me ask you one last question before moving ahead. Can we directly see an electric charge with our eyes? So answer is no. We identify charge by observing its effect, such as attraction, repulsion, or electric force. So this is very important point. So keep it in mind. Now we have an intuitive understanding of charge. Let's next step to define it scientifically. So let's move to the next slide and understand what is electric charge. Okay. So here is the slide. Let Okay. To minimize. Oh, yes. So now we have an intuitive idea about charge. Let's define it scientifically. So as you can see the slide, what is electric charge? So I'm writing the definition first, then we understand. Okay. So electric charge. So electric charge is a fundamental property of matter due to which it experience electrical force. Okay. So now don't memorize this definition. Let's understand it. Okay. So the first phrase is fundamental property of a matter. So what do you mean by fundamental property? Suppose I ask you, what is the basic property of an object? Okay. So you say mass, volume, density. These are the basic properties of an object or matter. Okay. So exactly in the same way, electric charge is also a fundamental property of a matter. मतलब चार्ज किसी ऑब्जेक्ट पर बाहर से लगाया हुआ लेबल नहीं है. ये उस ऑब्जेक्ट या पार्टिकल की अपनी इंट्रिंसिक प्रॉपर्टी है. Now let's look at the next part of the definition, which is due to which it experiences a electric force. Okay. Imagine there are two charged particles. जब हम उन्हें एक दूसरे के पास लाते हैं तो उनके बीच एक इंटरेक्शन होता है. कभी वो एक दूसरे को अट्रैक्ट करते हैं, कभी वो एक दूसरे को रिपेल करते हैं. सो ये इंटरेक्शन किस वजह से होता है? बिकॉज बोथ द पार्टिकल पोजेस इलेक्ट्रिक चार्ज. अगर चार्ज ही ना हो तो इलेक्ट्रिक फोर्स भी एग्जिस्ट नहीं करेगा. ओके. नाउ वी move to the next, which is representation of electric charge. So it is represented by the capital Q or small q. Small q is usually referred to a point charge, and the capital Q is often used for the total or large charge. Okay. आप न्यूमेरिकल में दोनों सिंबल्स को फ्रीक्वेंटली देखेंगे, so don't get confused. Next is there are two type of electric charge, which is positive and negative. अभी हम इनको डिटेल में पढ़ेंगे. Okay. Now we write the SI unit of a charge. The SI unit of electric charge is coulomb. coulomb, and the symbol is C. Okay, and one more important thing is to remember is 1 coulomb is very large amount of charge. Okay, later in this chapter we will understand that charge is on a single electron is only 1.6 into 10 raised to the power minus 19 coulomb, which is extremely small. Okay, so now we now let me ask you one question. How many type of electric charges are found in nature? So the answer is there is only two type of electric charge found in the nature, which is positive charge and negative charge. Okay, that's all. Nature has not discovered any third type of electric charge. और एक कॉमन मिस्टेक जो हर स्टूडेंट करते हैं वो कहते हैं कि न्यूट्रल इज द थर्ड टाइप ऑफ चार्ज. नो, न्यूट्रल इज नॉट अ टाइप ऑफ चार्ज. न्यूट्रल का मतलब है कि पॉजिटिव और नेगेटिव चार्जेस इक्वल हैं, देयरफॉर द नेट चार्ज बिकम्स जीरो. ओके, सो न्यूट्रल का मतलब है कि न्यूट्रल का मतलब है कि न्यूट्रल मीन्स इक्वल नंबर ऑफ पॉजिटिव एंड नेगेटिव चार्ज. Okay, this is not the third type of charge. This is equal number of positive and negative charge, not a third type of charge. काफी स्टूडेंट्स गलती करते हैं कि इसको थर्ड टाइप ऑफ चार्ज मान लेते हैं, जबकि ऐसा नहीं है. ओके, एंड द we have to write the nature of the charge. So the nature of charge is scalar. Okay, because electric charge does not have any direction. Electric charge only has a magnitude. So this is the scalar quantity. So the nature of electric charge is scalar. Now interaction between charge. We remember the most fundamental rule of electricity. Okay, now we remember the most fundamental rule of electricity, li- like charges repel each other, whereas unlike charges attract each other. That means positive positive repulsion, negative negative repulsion, and positive negative attraction. We can discuss later in the upcoming slides about the interaction of charge in detail. Okay, लेकिन आप इस रूल को कभी मत भूलना, बिकॉज ऑलमोस्ट एवरी कंसेप्ट इन इलेक्ट्रोस्टैटिक स्टार्ट फ्रॉम द इंटरेक्शन. सो पॉजिटिव पॉजिटिव रिपल्शन, पॉजिटिव नेगेटिव पॉजिटिव नेगेटिव अट्रैक्शन, एंड नेगेटिव नेगेटिव रिपल्शन. ओके, पॉजिटिव पॉजिटिव रिपल्शन, पॉजिटिव नेगेटिव attraction, and negative negative repulsion, negative positive attraction. Okay, so let me ask you one final question. Suppose I have two positively charged sphere. If I bring them closer, what will happen? Answer in the comment section. Okay, so now we know what electric charge is and how charge body interact, but another important question still remains. Where does the electric charge actually come from? Okay, so to answer that we need to understand the structure of atom. Let's move to the next slide to understand the structure of an atom. Okay, so in the previous slide we understood what electric charge is, but now an important question arises, where does the charge actually comes from? So to answer this we need to look inside the atom. Okay, so as all you know, every material around is made up of tiny particles called atom. Now let quickly revise the basic structure of atom. Okay, so at the center of an atom we have a nucleus. At the center this is a nucleus. Okay, let me write clearly. So nucleus. Okay, around the nucleus electron revolves in different energy levels or shells. So the These are the electrons. They are moving in shells around nucleus. These shells are called energy levels. Okay. Now let's focus only one particle related to charge. Okay. First is, so there are two type of particles, which is proton, which contain positive charge, and another is electron, which contain negative charge. Okay. And neutron has no charge, and neutron lies in a nucleus. Okay. So out of these three particles, which one is neutral? So neutron is neutral. Now another important question arises: if an atom contain equal number of proton and electron, what will be the net charge? Okay, so the net charge is zero. The atom is electrically neutral because the positive and the negative charge cancel each other. So this is neutral sodium atom because it has 11 proton and 11 electron. Okay, for example, any hydrogen atom is one proton and one electron. So the proton contribute plus E and the electron contribute minus E. So the net charge becomes zero. इसलिए normally जो object हमारे around होते हैं वो electrically neutral होते हैं. Okay. Now come to the most important point. Which particle is actually responsible for the charging of a body? Okay. So many students think that protons move from one object to another, but that's incorrect. सिर्फ इलेक्ट्रॉन ट्रांसफर होते हैं, प्रोटॉन न्यूक्लियस के अंदर स्ट्रांगली बाउंड होते हैं, इसलिए नॉर्मल कंडीशंस में वो एक एटम से दूसरे एटम में मूव नहीं करते. ओके. इलेक्ट्रॉन्स जो होते हैं वो कंपैरेटिवली लूजली बाउंड होते हैं प्रोटॉन के कंपैरिजन में, सो दे कैन इजीली मूव फ्रॉम वन बॉडी टू अनदर. दैट्स व्हाई एवरी electrostatic phenomena is actually the result of transfer of electrons. Okay. So now let's understand this with two situations. First is loss of electron. So okay, this is a neutral sodium atom. Suppose an atom electron one electron. Okay. तो अब इलेक्ट्रॉन कम हो गए उसके पास, लेकिन प्रोटॉन्स उतने ही हैं. जैसे कि यहाँ पे देख सकते हैं 11 प्रोटॉन है, लेकिन जो इलेक्ट्रॉन्स की वैल्यू है वो 10 इलेक्ट्रॉन बचे इसके पास. ओके. सो मतलब पॉजिटिव चार्ज जो है यहाँ पे ज्यादा हो गया, देयरफॉर द एटम बिकम पॉजिटिवली चार्ज. सो सोडियम आयन Na plus. So this plus charge representative represent that this atom contain positive charge. Okay. So if the situation is reversed, now suppose an atom gain two extra electrons. So अब electrons की का number proton से ज़्यादा हो गया, so the atom become negatively charged. Okay. So remember this exam for the exam point of view. The body become positively charged by losing electron, and the body become negatively charged by gaining electron. Okay. So only the electrons move, not proton. Okay. अभी हम आगे जाके इसको डिटेल में पढ़ेंगे कि इलेक्ट्रॉन रिमूव करने पर कितना चार्ज आता है और इलेक्ट्रॉन पॉजिटिव या इलेक्ट्रॉन ऐड होने पर कितना चार्ज एटम के पास आता है. ओके. मास के बारे में भी बात करेंगे कि मास इंक्रीज होता है डिक्रीज होता है. उससे पहले लेट मी आस्क यू वन क्वेश्चन. सो इफ अ न्यूट्रल मेटल स्फीयर लूज 5 इलेक्ट्रॉन, will it become positively charged or negatively charged? So you have to answer in the comment section. Okay. If a neutral metal sphere loses 5 electron, will it become positively charged or negatively charged? Okay. So now we know where electric charge comes from and why the particle is responsible for charging a body. The next question is, how much charge does an electron or proton actually carry? Okay, so let's move to the next slide and understand the magnitude of electric charge. Okay, this is slide 6. Now we know that the electrons are responsible for the charging of a body. The next question is, how exactly does neutral body become positively or negatively charged? Okay, so let's understand this with the help of diagram shown in this slide. Now first look at the neutral atom. Okay, look at the neutral atom. मान लीजिए कोई एटम है, ये न्यूट्रल है. Okay, this, if there is 10 proton or 10 electron, then the positive and negative charge cancels each other. So this contains 10 electron and 10 protons. Okay, so the negative and positive charge are equal, so the net charge on this electron on the atom is 0. Okay, so this is the case 1. Now suppose a neutral atom lose 2 इलेक्ट्रॉन. ओके, यहाँ पे देखते हैं कि एक न्यूट्रल एटम ने 2 इलेक्ट्रॉन्स को रिमूव कर दिया, लूज कर दिया, या फिर तो हैज द नंबर ऑफ प्रोटॉन चार्ज्ड, हैज द नंबर ऑफ प्रोटॉन चेंज? नो, the proton are still inside the nucleus. Okay, so only the electron have left the atom. Okay, or now the number of electron is 8 electron and number of proton is 10 proton. So the पॉजिटिव चार्ज जो है अब वो इस एटम पर ज्यादा हो गया. ओके, so therefore the atom acquire a net positive charge. So remember the statement: a body become positively charged by losing electron, not by gaining proton. Okay, this is very common mistake made by students. Another is gain of electrons. So जब इलेक्ट्रॉन गेन होंगे तो इसका रिवर्स होगा, नंबर ऑफ इलेक्ट्रॉन्स की वैल्यू जो है वो बढ़ जाएगी, जिसकी वजह से बॉडी नेगेटिवली चार्ज हो जाएगी. ओके, so a body become negatively charged by gaining electron. So the important concept is I want of you to remember one very important: during charges only electrons move from one body to another. Protons never move under normal condition because they are tightly bound inside the nucleus. Okay, और ये किसी भी कॉम्पिटेटिव एग्जाम के पॉइंट ऑफ व्यू से ये पॉइंट बहुत इंपॉर्टेंट है. ओके, ड्यूरिंग चार्जिंग normally only electron move from one body to another. Okay, let's check whether the concept is clear or not. Suppose a neutral metal sphere lose 5 electron. So will it become positively charged or negatively charged? You have to answer in the comment section. ओके, सो अब एक थोड़ी सी समरी है कि अगर एटम इलेक्ट्रॉन लूज करेगा तो वो पॉजिटिवली चार्ज होगा, गेन करेगा तो नेगेटिवली चार्ज होगा, और इलेक्ट्रॉन ही ट्रांसफर हो सकते हैं, प्रोटॉन न्यूक्लियस के अंदर टाइटली बाउंड होते हैं. ओके, so now let's move to the next slides. So far we have understood how body become positively and negatively charged, but another important question still remain: how much charge does one electron actually carry? Let's move to the next slide. No, we don't have to move to the next slide. We will see in this slide how much charge does one electron actually carry. Okay, now everyone, before now everyone, before we solve any numerical, let's look at the reference value given at the bottom of this slide. These values are very important because we will use them throughout this chapter. So in the first row, you can see that the charge on one electron. So generally the charge on one electron is minus के 1.6 into 10 raised to the power minus 19 coulomb. Okay, negative sign tell us that the electron has a negative charge. Okay, and the mass of the electron is 9.11 into 10 raised to the power minus 31 kg. Now look at the second row. This is for the proton. So the charge on one proton is plus 1.6 into 10 raised to the power minus 19 coulomb. Okay. Notice something interesting. The magnitude of charge on electron and proton is exactly same. सिर्फ साइन डिफरेंट है, इलेक्ट्रॉन नेगेटिव है और प्रोटॉन पॉजिटिव है. Now look at the mass. So the mass of proton is 1.67. Let me write it clearly. 1.67 into 10 raised to the power minus 27 kg. ओके, अगर हम कंपेयर करें तो प्रोटॉन का मास इलेक्ट्रॉन से लगभग 1836 टाइम्स ज्यादा है. ओके, प्रोटॉन का मास जो है वो इलेक्ट्रॉन्स के मास से 1836 टाइम्स ज़्यादा है ऑफ मास ऑफ इलेक्ट्रॉन। नीचे लिखना था प्रोटॉन का मास 1836 टाइम्स ज़्यादा है मास ऑफ इलेक्ट्रॉन के। That's why the electron can move easily from one body to another, whereas proton remain fixed inside the nucleus. Okay, this is the reason why during charging only electrons are transferred. So now let me ask you another question. Which particle is heavier, electron or proton? Okay, answer in the comment section. Okay, therefore the reference values are not just the theory. In the next slide, we will use the value of mass of electron or charge of electron and proton to calculate the net charge on a body where electrons added or removed. So let's move to the worked example in the next slide. So till now we understood three important concepts. First is a body become positively charged when it loses electron, and a body become negatively charged when it gain electron. And the charge on one electron is 1.6 into 10 raised to the power minus 19 coulomb. ओके, सो अब देखते हैं कि इन कॉन्सेप्ट को न्यूमेरिकल में कैसे अप्लाई करते हैं। ओके, तो द इधर जो दिया हुआ है केस वन, केस ए, वी कैन से दैट लेट्स रीड द क्वेश्चन केयरफुली. So a neutral body gain 10 electron, find its net charge. Okay, so the question is neutral body gain 10 electron, net charge, find net charge. Okay, so the 10 electrons are added. So the charge on one electron is 1.6 into 10 raised to the power minus 19 coulomb. So the charge of 10 electron is 10 into 1.6 into 10 raised to the power minus 19 coulomb, and the exact answer is 1 minus 1.6. So here we can use negative signs because the electron has a negative charge. So the net charge is Q is equal to 1.6 into 10 raised to the power minus 18. Okay. So negative sign क्यों आया? Because we have added electron and the electron always carry negative charge. So whenever electrons are added, the body become negatively charged. Okay. Now let me ask you one question. If instead of 10 electrons we add 20 electron, what will happen? Will the charge become more negative or less negative? So you can answer in the comment section. Okay. Now case B. Here the 50 electrons are removed. Okay. Oh, so now let's solve the second case. This time the body loses 50 electron again. So the here n is equals to 50 electrons which is removed. So the charge on one electron is 1 point minus 1.6 into 10 raised to the power minus 19 coulomb. Okay. Since the electrons are removed, the body left with an excess of positive charge. Okay. So the charge removed due to the 50 electron is 50 into 1.6 into 10 raised to the power minus 19 coulomb. Okay. So if we calculate, we get the net value of the net charge is 8 into 10 raised to the power minus 18. So why? Okay. So because the body has lows electron and the positive charge become dominant. That's why there is a positive sign here. So the question is why there is a positive sign and no negative sign. So because the body has lows electron and the positive charge here become dominant. Okay. So now I have another question for you. Suppose a neutral body gain 100 electrons. 100 electrons. Okay. Without calculating, can you tell me whether the answer will be positive or negative? Okay, so you have to answer this in comment section. Oh, comment. Comment your answer. So many students make mistake in numerical by using the wrong sign. So remember this shortcut. If there is a gain of electron, there will be a negative sign or negative charge. Or if there is a loss of electron, there is a positive charge, means positive sign. So if you remember these two statement, you will never make a single error in electrostatics numerical. Okay, so extra electron is gain of electron, means negative charge, means negative sign. If there is a deficiency of electron, means loss of electron, so positive charge and positive sign. Okay, now we know how to calculate the net charge on the body, but charge always transfer in arbitrary amount. Can body have a charge of 0.5 electron or 2.7 electron? So to answer that, let's move to the next topic, which is quantization or properties of a charge. We can study in the next slide. So let's move in the 8th slide. Okay. So before we study the quantization of charge, we have some more things to study, which is unit and dimension of charge. Okay. So let's study. Where is the cursor? Okay. Now that we know what electric charge is and how a body gets charged, let's discuss an important aspect. How do we express or measure charge? Okay. So every physical quantity has a unit. For example, length is measured in meter, mass is measured in kilogram, and time is measured in second. Similarly, charge also has its own unit. As you can see on the slide, the SI unit of electric charge is Coulomb. So here is SI unit. SI unit of charge is Coulomb, okay, which is represented by C. This is the unit that we will use in almost every numerical problem throughout this chapter. Okay, so the another unit is CGS unit. Okay, apart from the SI system, there is another system of units called CGS system. Okay, in CGS system, the unit of charge is state Coulomb. Okay, STAT COULOMB, state Coulomb, and this is also known as Franklin or Franklin. Okay, आज के बोर्ड मतलब अगर आप किसी कॉम्पिटिटिव एग्जाम्स की प्रिपेयर कर रहे हैं तो उसमें मोस्टली ऐसा यूनिट्स या जैसे कि गुलाम यूज करते हैं, लेकिन आपको पता होना चाहिए कि सीजीएस यूनिट में चार्ज को स्टेट गुलाम में मेजर कर किया जाता है. ओके, so the relationship between these two units is 1 coulomb is equal to 3 into 10 raised to the power 9 state coulomb. Okay, you don't need to memorize this its derivation, just remember its conversion if it's required. Okay, okay, let's move to the next topic is dimension of charge. Now let come to the most important part of this slide. So the dimension of charge. Instead of memorizing the dimensional formula, let's drive it. Okay, as we know that starting from the current, I is equals to Q upon T. Okay, where I is electric current, Q is electric charge, and T is time. Now let's rearrange this equation. Okay, so Q is equals to I into T. So we rearrange the equation Q equal to IT. Now let's write this dimension. So current has a SI base unit ampere and the time has a SI base unit second. So ampere dot second. Okay. So therefore the dimension is Q is equal to bracket A T. Okay. So let's write here Q is equal to the dimension of electric charge is A T. Okay. ये डायमेंशनल फॉर्मूला बहुत इजी है, इसको याद करने की जरूरत नहीं है अगर Q इज इक्वल टू आई टी याद है तो एग्जाम में आप खुद इसे डराइव कर सकते हैं। ये तो सिंपल सी वन टर्म डेरिवेशन है। सो नाउ लुक एट द बॉक्स ऑन द राइट साइड, इट रिमाइंड अस ओके सो हेयर A represents ampere which is the SI unit of electric current and T stands for time. Okay, measured in second. So in simple word, charge is nothing but current flowing for a certain duration of a time. अगर 2 एम्पियर करंट 5 सेकंड तक फ्लो करे तो टोटल चार्ज ट्रांसफर होगा Q is equal to IT से 5 to the 10 coulomb. Okay, so this is the simple and very useful in the next chapter. Okay, so I can give you a question for your homework. So if a current of 3 ampere flow for 4 seconds, okay, time is given 4 seconds. So how much charge is transfer? तो तुम्हें निकालना है कि चार्ज कितना ट्रांसफर होगा. ओके, सो दिस इज योर एच डब्ल्यू. ओके, सो let's summarize what we to study today. Yeah, okay, summary. So as a unit of charge is coulomb, CGS unit state coulomb, and 1 coulomb is equals to 3 into 10 raised to the power 9 state coulomb. Okay, a dimension of Q is A T. Okay, so far we understood the origin of charge and how a body get charge and its unit and dimension. So now it's time to discuss the most fundamental part of this chapter is properties of charge. Okay, so before moving to the next slide, let's quickly revise what we are learned in today's class. So today we start our journey into electrostatics. We understood what electric charge is and why it is a fundamental property of matter. Okay, then we discussed the origin of charge by revising the structure of atom and learn that proton carry positive charge, electron carry negative charge, and neutrons are basically electrical neutral. Okay, और अगर बॉडी इलेक्ट्रॉन लूज करती है तो वो पॉजिटिवली चार्ज हो जाती है और अगर इलेक्ट्रॉन गेन करती है तो वो नेगेटिवली चार्ज हो जाती है. We also learned that important point that only electrons are transferred during charging, while protons remain fixed inside the nucleus. Then we solve a work example to see how to calculate the net charge on the body. And finally, we discuss the SI unit of charge, coulomb, CGS unit, state coulomb, and derive the dimension formula of charge using Q is equals to IT relation. Okay. So in the next lecture, we will study the most important part of this chapter, which is properties of electric charge, such as conservation of charge, quantization of charge, and additivity of a charge. These concepts are frequently asked in competitive exams, so don't miss the next class, okay? So before the next lecture, I would recommend you to revise and once today's concept once and solve a basic few questions on charge calculation using Q is equals to NE and Q is equals to IT. Okay, so thank you everyone. If you have any doubt regarding this today's lecture, feel free to ask in the comment section and see you in the next class. Okay, bye.